So we are today again streaming on the Sardine project. So we had a week off. I had an event last week on the Tuesday morning, so I couldn't stream. But now we're back. We're back from we're back. It's actually been a week and a week off, and it's interesting because yesterday I was trying to do a recap, and even trying to get back into what we were doing was a little bit difficult because just having had that 1 week break, focusing on other things, and then trying to get my brain back into Sardine was not easy. And so maybe actually today I'll be doing a little bit of that work actually here on stream. Got my coffee. So I'll be doing a little bit of the work here on stream to figure out what we were doing, where we left off, what needs to be done for the future, or what's the next step. So just for those who might be joining us for the first time, so the goal is so we've had this observation, and we are actually getting ready to publish the paper from whence that observation comes from, which is actually has to do with this project we've been working on the dog gut microbiome for a few years now, and we're using nanopore data for that. Very, very happy with nanopore. But what we noticed too is that if we just use the nanopore without the polishing with short reads from Illumina, then we see that there's an excess of small genes. So these are because we have these small indels from the nanopore data, and that shows up in mispredicted genes. And so and tools like CheckM2 actually capture that very indirectly, because CheckM2 actually, if you think about it, what CheckM2 is checking, if you allow me repeating the word check a million times, so what CheckM2 checks is the gene set, not the actual nucleotides anymore. It goes from nucleotides to genes, predict genes, and then it checks whether that gene set makes sense actually operating in the KEGG orthologous group, the KO space. So we tried to see if we could adapt that to work with see if there's maybe some of these KOs are exceptionally small, which would be an indication that they are not real, or a truncated version. We played around. We've been doing most of this work with simulation, and then in the last week in the last couple of weeks we decided to try to, instead of using KOs, to try to use eggnog OGs. So some sort of similar concept, so eggnog orthologous groups, except that instead of using KOs, which would have worked, and it would have had the advantage that it would be very nice to do this based on the same results as CheckM2, we were going to do eggnog. Right. So let me see where we left off. So I'm going to put the fade back into to my screen, and you should be seeing my screen now. Yep, there it is. So so here I am. But so we've been doing all of this. Actually, we've been using Pixie. So I'm gonna activate the Sardine environment. Okay. What did I? Oh, okay. Oh, I did a little bit. Okay, so I had. Yeah, I had. Okay, I'm gonna just remove those things. Oh, sorry, jug. Do that again. Sorry, I want this to look. Sorry, I'm trying to make the fonts a bit larger so that they show up on the stream, but this was a bit too much. Okay, so I ran all of this. Okay. The thing we didn't run was cleaning up the FASTA files. We can do that. We can do that in a second. Let's see, and then okay, and I think, and what? And then we had some. Did we have some stuff in the work in progress branch? What was there? Oh, okay. So this code here. Undereplicate. Okay. Undereplicate. Okay, that's a word, I guess. Oh, I'm trying. Okay, we create. All right, I guess we created this. Okay, I see. So we created this code. Right. And then the other thing we had done was we had downloaded the we had downloaded the GMGC emapper annotations, right? So great. Okay, great. So we have here these emapper annotations. Okay, so this is all right. So go back. The goal is to use. So we're trying to use the GMGC v1, particularly the subset that is a subset that is only complete genes. And so we can, if we have their eggnog mapper annotations, so they're OGs, then that would be our baseline, because that's how big. So we could use that as a baseline and then know how big the OGs are, and then we can use the OGs we have from our simulation and use that as a comparison point. Okay, does that make sense? Okay, so I'm just gonna start typing. So we also want to we want to know only the complete ones. Okay. So we could do it this way. Just gonna. So this will create the data. So this will create a set of all the complete, or only the complete FAA, or sorry, only the complete GMGC genes, and then we can use this. So we've downloaded the pre-computed annotation of all of the GMGC unigenes. So a unigene the word we use, to this 95% nucleotide cluster, and that includes everything. Includes complete genes and includes some partial genes. But we don't want the partial genes. We only want the complete ones. So we also got the list of the complete ones as a FASTA file, and now we're just parsing the FASTA file to just get the headers as a set, and then we will use that to then filter out the other file. So a lot of what we're doing here, I mean, this is just more standard data science type processes. We have tables of tables and there's a lot of filtering tables, matching IDs. So a lot of this is not even very biologically driven. It just happens that the data that we have in those tables are gene annotations, and so I can see I've been trying to figure out how to get so on my screen my camera is very sharp, and then when I see the YouTube, the camera is a bit fuzzy. I'd like to fix that at some point. All right, so so this is a bit slow, but it will eventually finish. Let's leave that running, and then see. So this would probably so I guess the idea is that this seems to where does emapper oh dear come from? Yeah. Okay, you don't. Okay, that. Oh, okay. Sorry about that, guys. I think I made a sorry, I think I computed some of these things on the cluster, and I guess I didn't copy all of the files over. So let me give you 2 seconds. I thought I had done that. Okay, give me 2 seconds. Okay, all right. I guess this was maybe. All right, this will take a little bit longer, but it will get done. Okay, so that's the emapper. Oh dear. So that's anyway that. Oh, okay. Just like this. Okay. No, I'm not sure. Okay, I'm not sure exactly. Not sure exactly what I was. Hash to original. Expanded. Okay, this might be, yes. Okay, so this is what. All right. So this is what we would have gotten, except that query and original are switched around. But this is what we would have gotten had we run eggnog mapper on everything, right? And so yeah, so for example, these ones happen to be the same, and we just, yeah. Right, okay, so this is, so let's call this expand emapper. So we need emapper out there. Yep. Spoiler is imported at the top level. Nope. Where are the sec maps? Yeah, but this would, this should work. It's not emapper out there. It's not a, I thought it was an, it's not a directory. Emapper out, it's a prefix. Okay, this is, yeah, this is better. Okay, so now let's see. So I just want to do one. Meanwhile, okay. Meanwhile, that one finished. I wanted to see whether this would run. Okay, it's running one. Okay, jug max tasks equals 1. I mean, that means it's gonna, unless I've misspelled the environment variable, I believe that means it will run just one time. Yep, just one. Okay, and that should work. Okay, and today we are 4th and 8th, right? Oh. Okay, we're gonna do that in a second. The same results as if we had okay, perfect. Go to okay. All right, so this is still in the let me just, so if I merge the work in progress, fast, forward, what I get. Yep. And I'm actually gonna squash that. Yeah. So in the main branch, we did that in. So here in the main branch, we did that in one step. We didn't have this intermediate step. Let's keep the main branch, the history a little bit cleaner. Okay. Right. We'll take care. Now let's see. In the meanwhile, this has run. We have, let's just, yep, 95 million. That's about right. And so. Everything's always a little bit slow when I'm running this on stream, because I'm also running the whole streaming software. So also, and this is an issue with this is an issue with IPython, which is if you have something like a very, very large set in your environment, then auto-completion is going to sometimes stop because it's processing. It's frankly a performance bug, but what can you do? So we still have this length by KO that we need to go back to at some point using length by eggnog OG. So this is what we are working towards. So here we have this file, right? And so if we get something like this, query, and then then now eggnog OG, and then the length, this would probably then be very easy to replace one by the other. Okay. This one. Okay, I don't know why this is so slow. Oh, I know. Yeah. So this is a it's a known. We've dealt with this before. So when Polars reads a JZip file, it's very slow, and this is another performance bug. It decompresses. Okay, George Leitão says, yes, bioinformaticians do this. Yes, we do this. Yeah, I mean, technically, maybe it would be nice to compress or to convert to Feather, but yeah. Okay, Okay, not any better, to be honest. Maybe I have an old version of Polars. Hi everyone, welcome back once again. So everything crashed. Everything crashed. I did something that just used way too much memory, and then everything just stopped, and eventually I think the stream went down, and now I'm back. So much for polars being more efficient. So what I was trying to do, I was trying to read. Instead, what I'm going to do is this. I'm going to so this is what I wanted actually. So check that I can read it. And I'm gonna this comes now to something has to do with eggnog, where eggnog maps. So there can be multiple OGs, multiple orthologous groups, because it takes the tree, the tree of life into account. And so what we want is the higher level one. So these are all of them. So let's see, eggnog. So this would be all of them. So this is some identifier at this 1239. That's some taxonomic group. These are all different taxonomic groups, and the ones we want are actually 1, which is the root, or 2, which is bacteria. So let's just write a simple little thing. I think there's always an at. Otherwise, let's just return. Okay, let's do it this way. Yeah, so this is what I wanted. Yeah, this would work. This would work quite well, in fact. Okay, let's go back to maybe our comfort zone. It's more like this. Yes, sorry, s equals s with columns, okay. G equals nog 1 OG. Let's call it 1 OG. Oh, this looks terrible because it looks like OG1. Let's say OG1. Yep. Oh, it's query name. It had, oh, it was correct. We have faster. Yep. Complete sizes. So this should. So this would also work, and then yeah, this would also work. Yeah, this would work. Might take a little bit of time, but this is what I would want. Yeah, we'd end up with query name, OG, size, where size is, let's call it AA. It's AA size actually, because these are AAs. Okay, this is gonna take a while. I'm gonna interrupt this. Forgot it's step 5. Nope. No, I forgot what's the command to. Just gonna interrupt thing just to check the code line complete sizes. Yeah, it's about right. What is that? About 30? Yeah, okay, so we were about 30. Yep, this is about this is correct. This is correct. Oh. Oof, now it's gonna okay, sorry. Before I crash the whole thing again, let's just kill it. Okay, let's sorry. Let me do something a little bit differently then, because this is terrible. Because in principle, this we should be able to scan this. Actually, no. Let me do it slightly differently. Let's go here to data. Let's just write a Yeah, let's do it this way. So yeah, let's do it this way. Simplifies a lot of things. No. Uncompress large files to save space. No, actually no. Uncompress large DSV to folders. And just rewrite that a bit. Okay, yeah, this is going to be a huge file, so we very much do not want. Yeah. Let's just load. Let's load 1,000,000. What do I call this? What if instead of read I do scan? Does this work? Okay, this this would work. Okay, so what? This would work. Alright, so that's not 5 million, just for. Okay. Okay, now in principle this should work. Okay, let's see what do we do about this. Let's get rid of the test stuff. We've done so this doesn't really need to be a JAG file, but just because everything else is, let's make it a JAG file. So just yeah, let's just do this. This works. Obviously, we can't run it yet because we're still waiting for the whole thing to uncompress. So let's not run it yet, but we can. Build table. Subset. Okay, let's just add that. I also didn't run the. I also gonna run run this all of the actually the cleanups and then also expanding the eggnog mapper results. I'll run all of that. I'll run this and then I'll have that ready for next stream. But in the meanwhile, let's with complete. All right, so let's. So these logs are just logs from running it. So everything's clean. I'm gonna push this, right? And so we are a little bit ahead of, well, oh, sorry, my screen is not showing. Oh, I messed this up again. Sorry guys, I really messed this up. Yeah, thank you. I got the message and yeah, the screen, the thing dropped. And then when I started back up, so I guess the last 20 minutes you didn't see the screen because I messed up the sharing. Yeah, sorry about that. Yeah, so I dropped the, then I dropped the, yeah, so it didn't, okay, I'm sorry about everything. So what I did in the last things that you didn't see was I built this script that extracts all of the OGs from the eggnog mapper. Sorry, I did this script that is going to build this complete OG table where it has all of the unigenes that are complete, and that so they will get selected out of the big table that includes both the complete and the partial unigenes, and then annotate them with the main orthologous group so that we're not dealing with more complicated things. Yeah, but sorry about that, guys. Yeah, so today, yeah, the problem was when it crashed halfway through, then I restarted it and I rushed that a little bit, and I wasn't looking at my second screen, which is where I have the chat. That's where I have and it's where I also have OBS, and somehow I wasn't looking at it. So I'm sorry about that. All right, I will try to post the recap and then maybe do a slightly longer recap this time. All right, thank you. I'll see you next week. Oh,